So see, what we have here is this, that this is a tank, of the shape of a cone, right? Okay, and its altitude is 10 meters, okay, radius is 4, and we already have water up to the height of how much? 8 meters in there. So we have to pump all this water out, right? Okay, and then we have to do this, that we have to compute, what do we have to compute? We have to compute the work done, okay, in that process. So does it make sense? Okay, good. So what we will do is, to accomplish this is this, that is, see this here. Let's look at this tiny, tiny disk of water, all right, of the volume that we have. Makes sense? And what I would do is, or what we would do is, that we will see how much work is done in pumping all this out, right? Okay, is that good? Okay, and 1 second.
So we have to dump out from the very bottom.
Well, this one gets pumped out from this level, okay?
But all the water.
Right, right, exactly. Okay, so all the water from here up to here, and I don't know why I have messed up in this portion. Actually, yeah, here the altitude of the water is different than what it should be. Let me just fill it up for you here. So what we would do is this, that excuse me. So what we would do is that we'll just compute the work done in moving all these like tiny volumes out and add them up, okay? And that will be the total work done. Is it making sense? Okay, so let's look at this tiny slab. All right, now we will go ahead and make the x-axis, okay, and axis means this. So let's pretend, 1 sec, let's pretend that this tiny slab that we see here is say delta y, right? Is that good?
Delta y is the height, or?
Oh, right. I'm just taking the y-axis as my, y as my variable. Okay. All right. So what I have is, so let's assume that that is delta y, right? Oops. Not see delta and delta. I had to book a ticket last night, and I got the same delta again. So that was a coincidence, wasn't it? Right?
Delta Airline?
Yeah, I had to book a ticket last night and see.
Again, you are going India?
Yeah, right. But that's okay. Let's concentrate on this now, okay? But I'm saying we gave a commercial for Delta Airline for, and I had to pay heavily for the ticket. But anyways, so say this part is delta y, right? And let's see.
The red
Yeah, this red thickness, this little bit, okay? And let's let the radius be, let's call it r, and we will be really informal here, okay? All right. So the thing is, so the radius is how much here?
4 meters.
No, this radius of this little slab, all right? R, right? So what happens then is that this tiny slab that you see, okay, its thickness is delta y, right? And radius is r. So what will be its volume? It's volume pi r squared, and then what? Delta y. Yeah. So h is what? That h is, okay, being played by who? Your delta y, right? So that's the volume of the slab here, right? Am I making sense?
Just this slab.
Just that red slab, okay? So volume, yeah, keep going.
What is this 2 means?
Louder. Oh, 2 is this. See, the thing is that see, yeah, right. See, this is already filled in up to
Oh, so
8 feet,
meters away.
8 meters.
Oh,
So 2 meters is the depth that's not filled in. So you have to
I got it.
lift. Okay, you got it right. So this is the volume of the let's say colored slab or red slab or whatever. Okay, am I making sense?
Yeah.
Good. Now we just have to do some little algebra or very basic geometry to see this. See, we are going to integrate with respect to y, right, aren't we? And this is r. Okay, so we have to do this, that we have to go and I mean we have to go ahead and figure out a relationship between r and y, right? Am I making sense? Okay, so let's see. Let's see here. Let's assume that this is how much? This is, oops, sorry about that. Let's assume that that is, okay, I'm very tired. So, one sec. I mean, of course, this is not delta y, so I'll just go ahead and here. So, this is y, right? Am I making sense? Okay. So, what happens if this
This is height is y.
yeah, this altitude is y, right? And this entire altitude is how much? That's a 10, you know that, right? Okay, and this is 4, isn't it, right? This radius is 4. So 4 to 10 is the same as r is to y. You agree with me? Because there will be similar triangles, right?
Yeah.
So 4 to 10 is the same ratio as r is to y, right? So we got what? R over y equals who? 4 over 10, which gives us, so yeah, we are doing better, right? So which gives,
solving for y. So.
sir, exactly. So 2 over 5 y, right? Makes sense? So this quantity becomes what then? Simply, I could have written this guy y here, right? So this quantity becomes what then?
We'll plug in that value.
Right, I'm just going to plug that value in. Let me do that fast before I leave that as a mistake. So that will be what? 4 pi over 25. Okay, y square, right? Let's keep it as delta y formally. All right, and we know all the theoretical requirements in the background. We are being slightly informal, so keep that in mind. Okay, all right, so far so good. Okay, so this is what? This is the volume of the slab, right? Am I clear? Let me call it,
Slab.
no, the tiny one.
Tiny one. Oh.
Right, of the tiny slab. Are we good so far?
Yeah.
Okay, now we are talking about water, right? And what's the density of 1 cubic meter of water? I think it's 1,000, 1 liter of water. Okay, 1 cubic centimeters of water weighs how much? 1 gram, right? So 1 cubic meter will weigh how much? 1 cubic meter of water will weigh. So you have see here, 1 gram is the weight of how many? 1 cubic centimeters, right? Okay, you said it right. So if I look at 1 cubic meters, right? Okay, so 1 kilogram is the weight of 1 cubic meters, right? Am I making sense? So what happens is that the weight of all this is how much? This quantity multiplied by 1,000, right? Makes sense? And 25 times how much is 1,000? 40. 25 times 40, and 40 times 4 will be 160, right? So how much weight we got that we have to pull? Okay, 160 y square delta y, right? Very good. Okay, so here we go. Just a second. I think we are hearing the voice from the other class, right? Aren't we? That will be good. So what we have is this, that we are learning 2 courses for tuition of 1, aren't we, right? No. Okay, so here, so this is the weight in kilograms, right? Am I clear? Now what you're going to do now is that you are going to lift this whole thing through how much distance? 10 minus y. Am I making sense?
Yeah.
So see, this is how much we are moving it off by, right? And this whole thing, this distance is 10 minus, let me write a different y. I don't like writing that different y, so let me still pull the same. Okay, are we good so far? So we are going to pull this up by how much? A distance of 10 minus y, right? So this is the force in kilogram, right? That I'm pulling up. So I have to, counter that with the same force. And how much I'm moving, how much distance am I moving it through? 10 minus y. So work done will be what? The work done will be the force times the distance, right? Okay, so so what do I do now is, I just multiply that with what? I multiply that with 10 minus y. It makes sense? And during this whole process, y varies from where to where? 0 to how much? 8, right? Very good. So all I have to do is, I just have to go ahead and integrate from 0 to what? 8, right? Makes sense? And this, I forgot something important. See this here? Pi, right? Pi here, and this is what I have to integrate, right? Now we have to bring the acceleration due to gravity, which is how much? 9.8 meters per second square. Okay, I have it up here. So actually we should have multiplied that by that quantity here, and now if you integrate, what do you get? You get this value, which is going to give you what? If I write in, or just these many joules, because this is what? Newton meters, the work done in Newton meters, which can be which is called joules, right?